Observing a pipeline fire from a distance involves understanding several factors related to visibility, scale, and potential hazards, even though the event itself isn't directly electrical. Firstly, consider the curvature of the Earth. At a distance of 50 miles, the curvature will cause the base of an object to be obscured. The amount of obscuration depends on the height of both the object and the observer. Using geometric calculations, one can estimate the amount of the object that is hidden below the horizon. Secondly, atmospheric conditions play a significant role. Atmospheric refraction, caused by temperature and density gradients in the air, can bend light rays and either increase or decrease visibility. Under certain conditions, this can allow objects to be seen from further away than would otherwise be possible, or it can reduce visibility. Thermal effects, such as heat shimmer, can also distort the image, making it appear larger or distorted. Thirdly, magnification significantly affects perceived size and distance. A 7x magnification will make an object appear 7 times closer and 7 times larger. This can greatly increase the ability to see details that would otherwise be invisible to the naked eye. Fourthly, consider the scale and intensity of the fire. Flames can reach considerable heights, depending on the nature and quantity of the fuel being burned. Pipeline fires involving natural gas or oil can produce flames that reach hundreds of feet into the air. Given the viewing distance and magnification, the apparent size of the fire can be estimated using trigonometric principles. Fifthly, transmission lines introduce additional considerations. The proximity of the fire to transmission lines creates a potential hazard, both from the heat of the fire and from potential explosions or ruptures of the pipeline. Electrical transmission lines typically operate at high voltages, ranging from 69,000 volts to 500,000 volts or more, depending on the transmission line. Contact with these lines can be fatal. Sixthly, concerning emergency response, gaining access to a remote location requires careful planning and coordination. Emergency vehicles, such as fire trucks, may need to traverse rough terrain to reach the site. Off-road vehicles and specialized equipment are often necessary. Coordination between different agencies, such as fire departments, law enforcement, and pipeline operators, is essential. Seventhly, potential hazards include explosions, toxic fumes, and structural collapse. Pipeline fires can generate intense heat and pressure, leading to explosions. The combustion of hydrocarbons can release toxic gases, such as carbon monoxide and sulfur dioxide, which can pose a health risk. Structural damage to the pipeline and surrounding infrastructure can also occur. Eighthly, investigating the cause of a pipeline fire is a complex process. Factors such as pipeline integrity, maintenance records, operating procedures, and external factors such as excavation damage or natural disasters must be considered. Forensic analysis of the pipeline and surrounding area is often necessary to determine the root cause. Ninthly, regarding safety precautions, it's crucial to maintain a safe distance from the fire. Obey all instructions from emergency personnel and avoid entering restricted areas. If you are downwind from the fire, be aware of the potential for toxic fumes and take appropriate precautions, such as wearing a respirator. Tenthly, environmental impact assessments are required. Pipeline fires can release pollutants into the air, soil, and water. The extent of the environmental damage depends on the size and duration of the fire, as well as the nature of the fuel being burned. Remediation efforts may be necessary to clean up contaminated areas. 11thly, the material of construction for high-pressure pipelines like the kind that would carry petroleum is usually a high-strength carbon steel. The specific grade of steel varies depending on the application, but common grades include API 5. The pipelines are designed to withstand high pressures and temperatures, and the steel is often coated with a protective layer to prevent corrosion. 12thly, pipelines are often buried underground to protect them from damage and to reduce the risk of tampering. The depth of burial varies depending on the location and the type of pipeline, but it is typically at least 3 feet below the surface. 13thly, the pipelines are equipped with cathodic protection systems to prevent corrosion. These systems use an external source of electricity to make the pipeline the cathode in an electrochemical cell. This prevents the steel from corroding. 14thly, the pipelines are regularly inspected to ensure their integrity. These inspections can include visual inspections, ultrasonic testing, and radiographic testing. Any defects that are found are repaired immediately. 15thly, consider that pipelines are equipped with emergency shutdown systems that can be activated in the event of a fire or other emergency. These systems can automatically shut down the flow of gas or oil through the pipeline, which can help to prevent further damage. 16thly, pipelines are also equipped with pressure relief valves that can vent excess pressure in the event of a fire or other emergency. These valves can help to prevent the pipeline from rupturing. 17thly, pipeline operators are required to have emergency response plans in place to deal with fires and other emergencies. These plans outline the steps that must be taken to protect the public and the environment in the event of an emergency. 18thly, the National Electrical Code, or NEC, may not be the primary code that would be involved in a pipeline fire incident. The NEC deals primarily with electrical safety, and while there may be electrical components associated with the pipeline infrastructure, the primary regulations governing the pipeline's construction, operation, and safety would fall under other codes and standards. 19thly, codes and standards that would likely be relevant include regulations from the Pipeline and Hazardous Materials Safety Administration, or PHMSA. The HMSA is the federal agency responsible for regulating the safety of pipelines in the United States. They have a comprehensive set of regulations that cover all aspects of pipeline design, construction, operation, and maintenance. 20thly, API standards would likely be used in the design and construction of the pipeline. API, or the American Petroleum Institute, is a trade association that develops standards for the oil and gas industry. These standards cover a wide range of topics, including pipeline design, construction, and operation. 21stly, state and local regulations would also apply to the pipeline. These regulations vary from state to state and locality to locality, but they typically cover things like permitting, zoning, and environmental protection. 22ndly, the NEC could become relevant if there were electrical systems directly affected by the fire or if emergency electrical work needed to be performed during the response. For example, if electrical equipment was used to operate valves or pumps along the pipeline, or if temporary power was needed for emergency lighting or communication equipment. 23rdly, in situations where electrical work is being performed in or around hazardous locations, such as those where flammable gases or liquids are present, the NEC has specific requirements for electrical equipment and wiring. These requirements are designed to prevent explosions and fires. 24thly, electrical equipment used in hazardous locations must be intrinsically safe or explosion-proof. Intrinsically safe equipment is designed to not produce enough energy to ignite a flammable atmosphere. Explosion-proof equipment is designed to contain any explosion that may occur within the equipment. 25thly, wiring in hazardous locations must be installed in conduit or cable systems that are designed to prevent the escape of flammable gases or liquids. 26thly, all electrical work in hazardous locations must be performed by qualified electricians who are familiar with the NEC requirements. 27thly, while the NEC may not be the primary code involved in a pipeline fire, it is important to be aware of its requirements if electrical work is being performed in or around the pipeline. 28thly, consider that electrical grounding is crucial for safety. Proper grounding ensures that stray currents are safely conducted to the ground, minimizing the risk of electric shock and preventing damage to equipment. Grounding systems must be designed and installed in accordance with the NEC. 29thly, surge protection is essential to protect sensitive electronic equipment from voltage spikes and surges. Surge protective devices, or SPDs, should be installed at the service entrance and at critical equipment locations. 30thly, regular electrical inspections are necessary to identify and correct potential hazards. Inspections should be performed by qualified electricians who are familiar with the NEC. 31stly, electrical safety training is important for all workers who may be exposed to electrical hazards. Training should cover topics such as lockout-tagout procedures, safe work practices, and the proper use of personal protective equipment. 32ndly, personal protective equipment, or PPE, such as rubber gloves, insulated tools, and arc flash suits should be used when working on or near electrical equipment. 33rdly, lockout-tagout procedures should be followed to ensure that electrical equipment is de-energized before work is performed. 34thly, arc flash hazards must be assessed and mitigated. Arc flash is a dangerous electrical phenomenon that can cause serious burns and other injuries. 35thly, electrical equipment must be properly maintained to ensure its safe and reliable operation. Maintenance should include regular cleaning, inspection, and testing. 36thly, consider the coordination between different agencies. Emergency response to a pipeline fire requires close coordination between different agencies, including fire departments, law enforcement, pipeline operators, and environmental agencies. 37thly, the Incident Command System, or ICS, is a standardized management system used to coordinate emergency response efforts. ACS provides a framework for organizing and managing resources and for communicating between different agencies. 38thly, public communication is essential during an emergency. The public should be informed about the nature of the emergency, the potential risks, and the steps they should take to protect themselves. 39thly, media relations are an important part of emergency response. The media can help to inform the public about the emergency and to provide updates on the situation. 40thly, post-incident analysis is important to identify lessons learned and to improve future emergency response efforts. The analysis should focus on what went well, what could have been done better, and what changes need to be made to prevent similar incidents from occurring in the future.